There are lots of coastal processes, and we can break them down into basics such as erosion, weathering, mass movement, and transport. Erosion is just the wearing away of land by moving agents such as the sea. And there's several types operating at the coast, including one, there's hydraulic power, which is also known as wave pounding. That's where water from a wave enters cracks in the cliff face, compresses air within the cracks, and causes pressure to be exerted on the surrounding rock. That weakens it and breaks bits off. You might get some solution where weak acids react with certain rock types at the coast, or you might get abrasion. Now, that if you think sandpaper is abrasive, the sea can act in a very same way. Sandpaper, we use that, it's got a rough surface which we can rub across wood to make it smooth. Abrasion in the sea, rocks are picked up and carried within the waves and thrown onto the beach and cliffs. Or you might get some attrition. That's where rocks and pebbles carried within the sea hit against each other. So if we look at that sort of graphically, there we go, we've got hydraulic action, wave goes into the crack, wave goes out again, exerts a force, that gives us hydraulic action. Abrasion, rock goes up the coast, hits the coastline, break bits off. Or attrition, two rocks in transit hit together and bits break off. The next set of processes are transport processes. So this is just where sediment is moved, and these run in order of size. So big heavy rocks and boulders are rolled along the seabed in the process of traction. And so to remember that word, remember traction like a tractor's wheel. Saltation is a hopping motion. So think about the word saltation, like a hopping, hop, 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 saltation. So there, smaller stones and pebbles are bounced along the seabed. In suspension, really fine material is carried up the coast, and that's why a lot of our seawater doesn't look very clear if it's full of suspended sediment. If you took a glass of that and let it settle overnight, that you'd get a layer of clear water, and then at the bottom you'd have all the sediment settled out. And then your last transport process is solution, and that's where weak acids in seawaters dissolve certain types of rocks like limestone or chalk. Weathering processes break down rocks in situ or in situation. So they act upon the rock and break it down into smaller bits, and mass movement processes move them later. So here we've got the process of freeze thaw, which is an example of mechanical weathering. The Earth's rocks are filled with cracks and faults. It might rain and fill the crack with water, and then in the UK overnight, in the winter it might get colder, the water freezes, expands, and breaks bits of the rock off and expands the crack. We also got chemical weathering, where weak acids such as carbonic acid in rainwater can react with cliff faces and so on. This one's an example of biological weathering, so don't forget burrowing animals, worms, that sort of thing can break up soils in coastal areas, as can the action of tree roots. And then on your mass movements, we've got different types. These just three types. Okay, so landslides, there we can see a block plane, so we'll just pop that one back up. You see a block of rock with a dip slope down towards the sea, and the entire surface would move down over. Rock falls more direct on vertical cliffs, so we get rock falling vertically down after it's been weakened by weathering. And then on the rotational cliff slumping, rainwater adds weight to soils. We've got there, you can see the fracture where we might get a cliff collapse. The wave base will get undercut by erosion, weathering will weaken the cliff face. And then we might get a slump of material down towards the beach. Okay, so that's your slump, rotational movement, hummocky toe at the end, and then exposed scarp slope.